this video, we're just going to talk real quickly about average value, which certainly has some real-life applications, but we're going to focus kind of on the geometric interpretation of it today. The average value of a function, f of x on an interval a to b, is f of c. This value represents the average height of f of x on the interval, and also the spot where the rectangle f of c units high and b minus a units wide has the same area as the integral from a to b of f of x dx. This is the definition of average value. Now, I put a picture here, and here's what this picture represents. So we have a curve, f of x, and we find the area from a to b. Okay? So here's f of x, and we're finding the area from a to b. Now, the average value is the y value. Okay, so the average value is this y value right here that would create a rectangle that has the same base. You notice the base still goes from a to b, and the rectangle would have the same area as the curve does. And you'll look, they certainly do look like they have the same area. That's the average value. So we're trying to find the height of a rectangle that has the same base and same area as the curve. Okay? Now, if you think about this, if I tell you that we have an area, we've established that, we know what the area is, and we know what the base is. You know, we know the base is extending in our kind of general example here, our base is extending from A to B, and we want to find the height. Okay, so let me just make a little note here. We're going to find h. Of course, the way to do that is to divide both sides by b. So h, the height, the average value, is equal to the area divided by the base. Well, I've kind of generalized that over here because, remember, the integral represents the area. Let me just write that. This is the area. Okay. B minus a, the difference between the endpoints, b and a, this represents the length of the base. And f of c, the average value, that's the height. So to solve for h, we just divide by b. Okay, so in our kind of nice example here, we would divide both sides by b minus a. So it would be the integral from a to b of f of x dx divided by b minus a. Now, you typically don't see it written this way. You see it written this way instead. They are the same thing. Obviously, you know, if you were dividing, let's say b and a were 3 units apart, dividing by 3 here is the same as multiplying by 1/3. And this is the more kind of general form of average value that you see. Okay? And again, it's just finding the height of the rectangle that has the same base and area as the curve does. Okay, let's do an example. So I want to find the average value of these two things, one a graph and one a function. Well, this is the absolute value function, okay, on the left, so I'm doing the absolute value, and I'm going to find the average value from -1 to 2. So that means I'm going to integrate from -1 to 2, and I'm going to put up front 1 over 2 minus -1, like that. Okay, this is the average value. Well, the area right here, you know, we've got a triangle that's got a base of 1 and a height of 1, so this is 1/2. Here we've got a base of 2 and a height of 2, so this is 2. So our area under the curve is 5/2. Okay, and of course 1 over 2 minus -1 is 1/3. So we multiply those two together, and we get an answer of 5/6. This is the average value of our curve. Now if I were to go up top and try and draw that, remember that's just less than 1. So maybe just less than 1, kind of like this. If I started shading that in, I think you can see that the area of that rectangle certainly looks like it has the same area as the absolute value function does on that interval. Okay, so this is our average value. It's 5/6. All right, next. 4 minus x squared, or the square root of that. So we're trying to find the average value of that. We would do integral from 0 to 2. I don't really like the way I presented this problem because, to be honest, we shouldn't have this integral here. We should just be saying what's the average value of this function. Okay, that's what we're establishing from 0 to 2. Well, from 0 to 2, here's what this function looks like. It's a semicircle. I'm sorry, it's a quarter circle. 2, 2, like that. So, of course, the area of a circle is pi r squared, but we've only got 1/4 of it. So, 1/4 pi multiplied by 2 squared is just pi. So this, I forgot my dx, this is just pi. Okay. And, of course, this is 1/2. So 1/2 multiplied by pi is pi over 2. This is our average value. Pi over 2 is about 1.57, so if you went up top here, you know, there's maybe 1, 1.5 is right here. And I think you draw that and you look and you say, yeah, it looks like the rectangle and the semicircle, or the quarter circle, would have the same area. So that's it. That's average value. And again, you know, going back up here, the reason I cross this off, we're trying to find the average value of this function, not the average value of the integral of the function. I was trying to kind of get you started, and I should have just left that. But this is it. That's how you do average value.